This one is May 2019, paper 4, variant 1. The first part I will discuss the moles topic, if I can relate it to moles. So this is a full question related to moles. In the first part, hydrochloric acid produces salt, which are known as the chlorides. Magnesium carbonate, when it reacts with hydrochloric acid, it produces magnesium chloride, water, and carbon dioxide. A student used 50 cm cube of 2 moles per dm cube hydrochloric acid in experiment to produce magnesium chloride. We have to calculate the mass in grams of magnesium carbonate that is needed to react exactly 50 cm cube of 2 mole per dm cube hydrochloric acid. So the first part, we have to calculate the moles of hydrochloric acid. We have the volume of the solution, volume is 50 cm cube, and we have the concentration. So how to work out the moles from volume and concentration?
Multiply volume by concentration.
So we'll multiply both of them. So moles equal concentration into volume. But remember, the volume should always be in decimeter cube. Here the volume is in cm cube. So we have to divide by 1000 to convert into cm cube. So 50 divided by 1000, that will be 0.05. So we have the volume 0.05 and the concentration 2. So when we multiply both of them, it will be 0.1. So 0.1 moles of HCl are there. Next, we have to determine the number of moles of magnesium carbonate. So how the first part we get the solve by using a formula, then the second one will take a ratio. And what ratio we'll take? We'll take a ratio between hydrochloric acid and magnesium carbonate. So the ratio between them is 1:2, like magnesium carbonate MgCO3 and HCl. 1:2 is the ratio. So if we have in the question we have 0.1 mole of hydrochloric acid and X moles of magnesium carbonate. We cross multiply. So 2x is equals to 0.1 and x is equals to 0.1 divided by 2, which is 0.05. So this will give us the moles of magnesium carbonate. So by using a simplest ratio, we work out the moles of magnesium carbonate. Then we have to work out the relative formula mass of magnesium carbonate. How to work out the mass of magnesium carbonate? Because so we have to
multiplied by 100.
We have to calculate a relative formula mass. So to calculate a relative formula mass, we have to use a periodic table, like relative molecular mass or formula mass. We have to use a periodic table for that. And in the periodic table, so we will use a periodic table. We have magnesium carbonate, which is MgCO3, where magnesium is 24, carbon is 12, and oxygen is 16. So it will be MgCO3. So magnesium is 24 plus carbon is 12 plus oxygen is 16 multiplied by 3, 48. So 16 multiplied by 3, that will be 48. 48 plus 12, 50, and 50 plus 24, that will be 74. So relative formula mass, 84, because this is 60 will be there. For 16 multiplied by 3, 48 plus 12 is 60. 60 plus 24, that will make 84, not 74. So the relative molecular mass or the formula mass is 84. So first part we solve by using the formula, the second part by ratio, and the third by using a periodic table. So our answers, as we saw in the previous one, it was 0.1, this was 0.05, and this one is 84. Now we need the mass in gram. So how to get the mass in gram? So we have the formula moles equal mass in gram divided by molar mass. We need the mass in gram. Moles we have, which are 0.05. Mass in gram we want to find, and the molar mass was 84. So 84 is divided, other side it will be multiplied. So 0.05 multiplied by 84, that will give us 4.2 grams. So 4.2 grams of magnesium carbonate is actually used in this reaction. Is it clear, this question? How we solve? First use a formula, then ratio, then we use a periodic table, and then again formula.